Welcome to the Radiation Shielding and Radiation Source Search tutorial. In this training scenario, you will be operating two primary instruments, an Inspector 1000 and a PAC-I. You will begin the lesson using the Inspector 1000. If your Inspector 1000 is not already on, press the O key to bring up the device controls. Using the mouse, click and hold on the power button to start the instrument. You may close the device controls after the unit has powered on by pressing the O key again. Once the Inspector 1000 has powered up, enter the training room. This is training room number 1, where you will learn a bit about your primary instrument and about how shielding affects its ability to detect radioactive materials. The Inspector 1000 has an audible tone to help locate hidden sources. If you have completed RAD Tutorial 1, then you already know that the amount of radiation measured from a source becomes less with greater distance from the source. If you double your distance, the measured radiation is reduced to 1/4 of its original intensity. In other words, the measured radiation intensity from a source diminishes rapidly as you get further away, with 1/r² behavior. In practice, this makes distance an effective tool for reducing your radiation exposure, but also makes it difficult to find radiation sources that aren't nearby. A more detailed description of this principle, the inverse square law, can be found in the Search and Secure Field Guide, starting on page 7. Keep in mind that we are teaching for gamma radiation, not beta radiation. Beta radiation acts differently and the shielding properties are reversed from gamma. When you're ready, follow the arrows to position yourself behind the wooden shield. You now have about 1 inch of wood shielding you from the radioactive sources. Note the count rate for later comparison to the concrete, steel, and lead shields. Wood does not make a very good shield for gamma radiation. Identify the radiation sources now by pressing the O key to bring up the device controls. Click on the green circular Enter button on the Inspector 1000, or click on the isotope icon on the inspector's touchscreen to enter the nuclear identification function. Then click on the green circular Enter button on the device to start the isotope identification. Upon successful identification, you will notice that there are two sources present in the container in the center of the room, barium-133 and cesium-137. Put the inspector back into locator mode by clicking on the Home key, or click on the LOC button on the screen. If you have trouble navigating with the device controls up, you may press O on the keyboard to close the device controls. Press O any time to bring the device controls back up. Now go stand behind the concrete shield. The flashing arrow will help show you where to go. You now have about 1 inch of concrete between you and the radiation source. Note that the count rate of the instrument has decreased a bit more. Concrete is a better shield for gamma radiation than wood. Although concrete in greater thicknesses is used for shielding and is quite effective, this small width is not a very effective radiation shield. Using the device controls, perform another nuclear identification. Although the count rate is lessened by the concrete, you should still be able to identify the sources. Remember, if your device controls are not up, just press the O key on the keyboard to bring them up. Once the identification is complete, put the Inspector 1000 back into locator mode by clicking on the Home key. Go stand behind the steel shield indicated by the flashing arrow. Now we are using 1 inch of steel as a radiation shield. As you can see, the count rate on your device has dropped significantly. Since steel is a denser material than wood or concrete, it provides better gamma shielding with the same material thickness. Go ahead and run another nuclear identification and see what you get now. Depending on where you're standing and a bit of luck, you may still be able to identify the cesium-137 source, but you cannot identify the barium-133 source anymore. This is because the cesium-137 source has higher energy gammas, 662 keV, than barium-133 at 356 keV, and can therefore penetrate shield materials more easily. If you cannot ID the cesium-137 source, try moving closer to the steel shield. Note that the quantity of the radiation is different than the energy level of the radiation. Once the identification is complete and the instrument is back in locator mode, please remove the last shield. The flashing arrow will guide you. You now have about 1 inch of lead shielding you from the radioactive sources. Notice that the count rate has decreased to background levels on your instrument. Lead is an excellent shield for gamma radiation because of its high density. Run the nuclear identification on your device once again. This time, you won't be able to identify either radiation source. You can reference the Search and Secure field guide for this and more information on radiation shielding. Locate the shielding section starting on page 14. Please exit this training room to continue with the tutorial. In this next portion of this tutorial, we will be using the PAC-I as the primary instrument. Please change the equipped instrument by pressing P on the keyboard. Continue pressing the P key until the PAC-I is equipped. Good job. You are now equipped with the PAC-I as your primary instrument. If the PAC-I is not already on, pull up the device controls by pressing O on your keyboard. In the device controls, click on the power button to start the instrument. When the instrument is on, go ahead and close the device controls. Note that the PAC-I is a sensitive instrument ideal for searching wide areas. Now that you are properly equipped and ready, it is time to practice finding a source. There is a radioactive source hidden in one of the 4 rooms in this facility. You will use the PAC-I to determine which room it is in. Follow the path of the arrows to conduct a search of the rooms using the readout of the PAC-I. Due to natural background rejection, or NBR, you should investigate all PAC-I alarms. Be thorough during your search. Moving too quickly can lead you to miss things when it comes to radiation detection. When you have entered the correct room, you will receive instructions. You may begin your search now. Follow the path of the arrows to conduct an outside search of the rooms using the readout of the PAC-I. Enter a room when you think a source is contained within. Congratulations! You have successfully located the room with the hidden source. Now you need to identify the exact location of the source. To do this, you will need to switch to the Inspector 1000 as your primary instrument. Remember, press the P key on your keyboard to change the instruments and use the O key to open the device controls if you need to turn the instrument on. In this and other Rails training modules, you will be asked to find and tag sources. Sources are tagged by aiming the white crosshairs at the suspected location of a source and pressing the E key. Typically, you will be scored based on how close you get to the real source. To help isolate the location of a nearby source, rotate the avatar while observing the change in radiation. The intensity will vary due to the directional sensitivity of the device, as well as shielding from the avatar's body. Once the general direction is determined, you can further isolate the source location by manipulating the avatar's arm. Move the primary instrument in any direction by clicking and holding the right mouse button while moving the mouse. The standard localization technique is to sweep your arm side to side and up and down to help you determine the actual location of a source as shown in this video. Search the room with your Inspector 1000, and when you think you have found it, press the P key until you are no longer holding an instrument to see where the source is really hidden. The source is located in this box. If you weren't able to find it, you should scan the area around this box and get a feel for how you could find a similar source in the future. Let's run through a quick exercise using our newly found source. Press the P key until you have re-equipped yourself with the Inspector 1000. Find and walk to the blue flag to begin the exercise. If the Inspector 1000 is not in locator mode, open the device controls and click on the Home button to put the device into locator mode. Walk by the source location in the aisle. Don't stop in front of the box, but keep walking to the red flag. Then, look at the display of your instrument. The spike you see after walking by the source is a good indicator that you have walked past a source, and implies you should retrace your steps to see if you can verify the presence of a radiation source. Now do the same action, but this time run through the aisle. Hold down the Shift key to run, all the way to the blue flag. You will notice that the spike is significantly smaller, if at all visible. As you can see, moving too quickly can lead you to miss things when it comes to radiation detection. This is the end of this tutorial. Open the radio menu with Escape and select the Quit button to exit this scenario.